All right. Oh, centripetal force example. What is the centripetal force exerted on a 0.2 kilogram rubber stopper if it follows a circular path of radius 0.8 meters and completes a full circle every 0.9 seconds? Hints: we need to find two things to find our force. We need to find V, which is velocity. We need to find A, which is acceleration, in order to find force. Okay, so let's draw a quick picture. I'm going to put that up in a second. We'll go from there. So here's our circular path. Here's the center. Here's where we're stopped. We've got to make sure I draw it correctly, otherwise Skylar gets mad at me. Okay, so there's our rubber stopper and our circular path, right? Does that make sense? Okay. So how long is this distance right here? 0.8. Right? Yeah. How heavy is rubber stopper? 2.2. Okay. 22 kilograms heavy rubber stopper. Yeah. For like truck beds and stuff. All right. Anything else? Anything else we know? Time. Now that time, is it time or is it something else? It's big T. Why is it big T, Nan? What? Okay, so that's the time it takes to go all the way around, right? So it's called one period, right? Time for one complete rotation. So T equals 0.9 seconds. Is there anything else we know? Okay. Now, what keeps this rubber stopper going in a circle? The string. The string. Okay. So you said the string. What do you mean by the string, Caleb? The tension of the string. Perfect. So the last question we can really answer first. What force is responsible for the rubber stopper centripetal acceleration? Right? This wiffle ball on a string is a lot like the rubber stopper, right? There is a string attached to the wiffle ball. The string is what keeps the wiffle ball going in a circle. So when I swing it around in a circle, right, this wiffle ball experiences a centripetal force, which is towards my hand, because that's the center of the circle, right? But what keeps it going in that circle? The tension of the string, right? Because the string is what's pulling the ball towards my hand at every point in the circle. Right? So the tension is what's responsible for the centripetal force. Remember I told you guys yesterday that centripetal force can be any force. It's like a net force, right? It can be friction, it can be tension, it can be gravity, it can be electromagnetic attraction, it can be anything. In this case, tension is what's responsible for the centripetal force. Right? Does that make sense?
It sure does.
Sure does. Thanks. Alright, so we said we had to find a couple things. What things do we need to find? Velocity. We need to find velocity, right? So we need to find velocity. We need to find acceleration. And we need to find force. Okay. So that's kind of the order we're going to do things. We're going to find V, find force, find V, find A, find force. All right. So to find velocity, what part of this picture is important to me?
The radius.
The radius and the period, right? Because which equation am I going to use to find velocity? Number 1. Good. So we know velocity equals 2 pi r over the period, right? Right. So velocity equals 2 pi times 0.8 over 0.9. Does that make sense? Come to the realization that my decimal points are invisible from the back of the room, so I'm trying to make them larger.
It's really hot. Let's take my calculator.
What?
Wait, do you have new numbers?
Yeah. We do have new numbers.
Oh, we do have new numbers.
Nan, you are number 12.
What number?
So does that mean I'm 19 now?
I was
18,
3, right? But I was number 11.
Katrina, you're 17.
Oh, I went down.
Imani, you are...
3?
No. Am I still 1? Imani, Hayden, you are 5. Am I still 1? Yes, you're still 1. All right. So, what's our velocity? 5.59. Can I round that to 5.6? There's our velocity, right?
That was easy.
Velocity has a direction. Which way is the direction?
In towards the center. Wait, no, that's it's going.
It's a
Tangent to the circle, right?
Tangent.
So this velocity is always perpendicular to the radius. Okay? It's always perpendicular to the radius. Perpendicular? Yeah. Next one, let's find the acceleration. How do I find acceleration? Which equation should I use? 2, good. So AC equals V squared over R.
This is easy.
We just figured out velocity, right? Now we need to find acceleration. Okay. So we know the radius. The radius is what? 0.8. So AC equals V squared, 5.6 squared, over 0.8. So 5.6 squared divided by 0.8. Can you guys calculate that?
You want to get mine?
39.2.
So acceleration equals 39.2 meters per second squared. Now which way is that acceleration point?
Fourth now.
Toward the center, good. So the acceleration points towards the center. Right? So acceleration is towards the center. Towards. That's parallel to the radius. Last one, find the force. How do I find the force?
You do last time acceleration.
Mass of acceleration, right? That's Newton's second law, isn't it?
Yes.
Yeah, you sure it works here?
No.
We're going in a circle. Does Newton's second law still apply?
Yes.
Yes.
Of course.
Okay. That's why they're Newton's laws of motion. Okay? It still applies. Every situation on this earth, Newton's second law will apply. So FC, which just means it's centripetal, means we're going in a circle. FC equals ma. The mass of the rubber stopper was 0.2 kilograms. Right? I'll make sure we didn't forget that over here.
Yeah, this is kind of easy, and I wasn't even here.
Good.
So is it going to get way harder?
We'll see.
Aw.
I don't think it's going to get more difficult. Okay. But, so acceleration is 39.2. So to find our force centripetal, we do 0.2 times 39.2. 7.8?
7.8.
7.8?
7.84.
Alright, now which way does that force point? Towards the center.
You have to say that?
Yes, because force has a direction. And once again, what's responsible for that force again? What's responsible for that force?
That way.
Not the hand. The hand pulls on the...
Tension.
Good. Tension is responsible for that. Does that make sense? Okay. Now, guys, there is a way we can do this problem.
Together?
There's a way I can do these two steps in one. Okay. What equation would I use to do those two steps in one? Equation 4. Right? Equation 4 combines this equation and this equation, right? Force equals mv squared over r. Right? So let's figure out if we get the same result. So let's plug in 0.2 times 5.6 squared over 0.8.
See, now you just already made it.
Why are we doing this again?
Just showing you could have done the last two in one step. So it's the same calculation, we're just combining the last two. So these two, Kyle, I'm showing that we can do these two in one step. So if I didn't ask for the acceleration, which I didn't actually ask for the acceleration in this problem, then you can find the force by just doing this stuff right here. Find the velocity, then do this.
Oh, it's the same answer.
Okay.
Oh.
So what do you get down?
7.8.
7.8.
4.
You said if you don't want it for acceleration, you can put it.
Right. So in this problem, I didn't specifically ask for acceleration, so you could just do this step. Find the velocity, then do this step.
I get it.
If I asked for acceleration, then you'd have to do this. Okay. Does that make sense? Any questions? Any questions?